high time that I got down to a repair video here. And after my last video, which was stripping down an old 1956 Olympic 21-inch black and white television that I never successfully repaired, I need a repair video here. I'm hoping this will go all right. This is an EICO Model 425 oscilloscope that obviously has had some work done on it by me. I came across this back in the late 2000s, and I started to go ahead and fix it, but I never did. I don't remember precisely why I abandoned this, but it is internally untouched. The shop this originally came from shut down back in 1982, according to the guy's widow. So by the time they were cleaning what was left of it out, getting ready to use the building for other purposes, the televisions and radios, all of that was gone, but the test equipment remained, and this is part of what I claimed from that. Paid them a little money for it. Back then there wasn't, apparently, for some reason, nobody somehow had ever snatched this up before me. Part of the reason I didn't ever get around to it to begin with is I had a working oscilloscope. My Konar 250 over here, which is currently on the fritz, was serving me back at that time, and until recently it was, and I'm gonna have a video coming up on it pretty shortly. But in the meantime, I need an oscilloscope, and I was digging through and found this and remembered that I had put it aside and just never come back to it. It's got a knob missing, but other than that, it's all intact. Sweep range goes from 15 hertz to 75 kilohertz. Not the most range you'll find on oscilloscopes from this period. The Konar goes all the way from 15 hertz up to 500 kilohertz. So when I came by it, it took priority. So for some reason, probably parts and other projects I had going at the time, I just never came back to this. So what I would like to do, since the Konar is currently down, and I will need an oscilloscope for the 56 Olympic when I come back to it, and other projects here, I would like to try to get this thing up to a stable, usable condition at this point, doing the bare most minimum that I deem necessary for it. It's apparently a running when parked situation. It was still plugged in that building, that old television shop, which hadn't had power in decades. So this was hopefully pretty much a running when parked situation, and it just needs to be carefully revived. This ought to be as simple as projects I'm going to be taking on here get. It is apparently, other than the tubes, which I thought it had all the original tubes in it, but apparently I'm wrong. Most of them are GE or RCA, and I thought it had all the original tubes in it. That's the way I remembered it, but I plan to be taking on a lot of projects here in the future that probably a lot of people wouldn't touch with a 10-foot pole. But outside the tubes, it looks to be totally original as far as all the capacitors and resistors in it go. Let's see, we got a factory test date apparently on it, if it's still readable. Let's see, when is that 1955 or looks like March 13th, 1956. Wow. And he was still using this back in 1982. It would have been pretty woefully outdated for a lot of the televisions that were being built at that time, but the shop was in a very small community, and considering that majority of the work he would have been doing at that time would have been televisions manufactured in the 1960s and 70s, he was probably getting good service out of this still. Even the most basic oscilloscopes by the time this one was built were pretty versatile, and as time went on, they wouldn't have measured everything that somebody would have needed, but a whole lot of the basic measurements in television work he could have still been doing with this. And according to his family, it was the only oscilloscope he ever owned. So maybe this will fix on up for us. Underneath does appear to be actually all factory original. Totally untouched. At least since it was tested back in 1956. I don't have many projects to come my way totally untouched in this respect. So I want to be extra careful on this one. These capacitors right here, 0.5 microfarad at 400 volt. I'm afraid I'm going to have to cross my fingers on them, at least to some extent. I don't have any 0.5 or 0.47s even currently in my stock that are 400 volt rated or better, so I might, depending on how they check, take a chance on these. Short term, of course, they'll need to be replaced, but most of the rest of it if we can see through the spider webs. Absolutely pristine. Also, I'm noticing it's got a lot of roundy type resistors in it. Practically, with few exceptions, well, like here, the majority of its carbon comp resistor population seems to be roundy, and they don't have the best reputation for holding up right on and on with age. So I don't see any of them looking charred, so maybe they'll be all right. On that oil cap, it got a little sign of corrosion right here. So my fears on that are heightened some. And actually, is that a little bit of oil leakage right here? I hope not, but it appears to be. That capacitor falls right in line with the value of a lot of old microwave oven capacitors, but they wouldn't be suitable replacements because microwave oven capacitors have a bleeder resistor in them, which doubtlessly this one doesn't have. I think microwave oven capacitors all have about a 10 megohm bleeder resistor in them for safety for the serviceman. And in an oscilloscope, that'll make a huge difference. So fingers crossed to the nth degree now on this. Also, I just noticed they used a terminal strip just as a wire guide when they put this thing together. Don't think I've seen that before. Nothing tied to it, it's just a wire guide. Pretty cool. Got both sides of the AC line cord fused, and if these are good and the rectifier tubes are good, that'll bode well for the power transformer, which appears to have a hot spot in the laminations right here, but kind of hard to tell. And well, if the fuses aren't blown and the rectifier tubes aren't blown, it doesn't show any sign of smoke or leakage where the leads are coming out. So I'm still overall optimistic this is going to go pretty well for us, for me, because I do need one. And since I don't have a dual trace oscilloscope, it'd be kind of cool just to use multiple scopes, to have this and the Conar used as a dual trace oscilloscope, since I like doing everything the old-fashioned way. I'm going to start by, of course, testing and replacing probably as many of these caps as I can. I think I've got the majority of them except for these 0.5s at 400. So if they'll hold out for a while, hopefully, again, fingers crossed, I won't worry immediately about a distorted trace. If it's not distorting too badly, I'll just, my main concern is I don't want these suckers to leak and cause any damage. Other than that, I think I'll have pretty much all the other capacitors that this thing will require to get it fired up. I want it in a good, stabilized, usable condition, and since I'm working up a parts list for other projects coming up here, I need to get this thing at least far enough along to evaluate its condition and include in that part order anything it may be needing. But I'm hoping that this one will work out and be usable here for a lot of what's coming up. One thing I always do before I ever apply any power at all to old equipment like this is test the AC line bypass capacitors. And here they are right here. They're each 0.1 microfarad at 400 volt on either side of the AC line. You've got the AC line coming in right here, and it goes straight to these two 3 amp fast acting fuses. Each side of the line cord is fused. And I just checked these, and these are good. But I also connected to chassis ground here and tested both of these line bypass capacitors, and I've got my meter here set to the times 1 million volt scale, and from either side of the line cord, right here or the other side, I want y'all to see the reading I get on these AC line bypass capacitors. I'm going to start with this one, and then I'm going to test this one, and both of these connect directly to chassis ground. So here is the test on this one, and y'all can, all right, that was a probe slip, but here is the, let me stabilize the phone here. Here's the reading I get, and this is on the times 1 million scale here of resistance. Here's the first capacitor. One million ohms, slowly climbing. Let me get a good probe connection. Finally hitting 2 million ohms. This is using the very top scale on my meter here. And about 2.5 million ohms on that capacitor. And that's on this top one here. Okay, now I can measure these also straight from the line cord, but since I'm holding the phone, it's just easier to do it where they directly connect here on each side of the line fuse. Here's our other capacitor. Doing a little bit better, but y'all, these are absolutely, despicably, totally terrible. To apply power to an old piece of equipment like this, where the line bypass capacitors are leaking this bad, they would very quickly cook and destroy the primary winding on the power transformer. Leaving capacitors like this in circuit or not disconnecting them, or, you know, replacing them, that is a death sentence you are imposing on a power transformer in old equipment like this. So absolutely no way am I going to apply any power. There's no need to do a variac or a dim bulb here. There is no need to strain this power transformer if, looking at that, it has not at some point before this thing came to me been strained already. There is absolutely 0 point in putting any dim bulb or variac on this. That it's just going to kill the power transformer to do that. So I will not be applying power to this. But the next thing I want to do is I want to test the rectifier tubes. If a rectifier tube is bad, I'm going to have to reconsider the worth of this project. But like I said, it was plugged in still, even though the place hadn't had power for decades. This was still plugged in when they gave it to me, so I'm not looking so much for weak emission, although I would think they test pretty strong, being that they're relatively new General Electric replacements. Mainly I'm concerned about shorts, or if one is open, either of those conditions would have me suspicious that this thing might have a power transformer problem. I'm using a Jackson 103 tube tester, and on the 5Y3 test setup, 5-volt heater, plate set at 20, testing on circuits 3 and 6, and shows shorted on 7, so we're not going to worry about the short indicator lighting up on that one. The occasional little flash is just the result of the circuit switch being turned, so alright, we're on circuit 7, and there's our confirmation. So testing on circuits 3 and 6. So we're currently on circuit 3, and let's see how one side of this one tests. Alright, that's good. I'm happy with that. Circuit 3, 4, 5, 6. Strong and well balanced. Actually, it could test as long as it was touching into the green. I'd be comfortable with it. I don't take a tube tester's word as law, but I do like to see a balanced rectifier. So we'll go for the second one here now. And we'll go through, let's go ahead and, alright, shorted on 7 as it would be, so Circuit 3. Strong. Strong. Different tube testers will give different results, but like I said, I'm not really worried about anything other than are they dead or are they shorted? Generally, when you have a bad power transformer, you've also got a bad rectifier tube also. And this scope does not have these rectifiers paralleled, I noticed. So one rectifier is powering all of the input and amplification, and another rectifier is pulling the duty of powering the deflection. So feeling a lot better now that 2 rectifier tubes are good. Other than that, I think we've got 3 6SN7s, and I'll go ahead and run through them and go ahead and get an idea about the condition of all the tubes in this. I've got these woefully leaky AC line bypass capacitors disconnected now so they can do no harm. And I've also removed the rectifier tubes. I've got them out so no DC voltages are going to be developed in this. And I want to confirm the operation of the power transformer and also measure the voltages from it, just in case it does have a problem, and in the off chance that I may one day want to hunt for a replacement, I'll have an idea of what voltages to look for in searching for a replacement for this. It's not going to be carrying any load at all, other than it will be supplying the heaters for the triode tube section. That is the only load that it's going to be carrying, and those and the pilot lamp. Okay, coming up on a big moment here. Using the Variac, I've set the line voltage at exactly 115 volts. So I'm going to move my connections just right across the full high voltage secondary, and see what we get there. I'm going to go ahead and bump this up probably just to be on the safe side, since I have no idea what kind of voltage I'm going to get. I'm going to bump this on up to the 1500 volt AC range to begin with, and I'll bump it back down to 500 for a more accurate measurement if it's less than 500. So here we go. This will be the first time this scope has had power applied to it in any form. in at least 40 years. Okay. Let's see. Alright, looks like we have actually got across the entire secondary. I'm glad I bumped it up another range. Let's see. 1500 volt. Yeah. We've got about 745 volts, looks like, across the entire high voltage secondary. Okay. What I want to do now, I hope my finger wasn't in the shot for all of that. I want to go to ground. I'll go ahead and record. Yeah, I'm into owning my mistakes here. And I screwed up the original diagram I had for the power transformer in this scope pretty badly. I'm so used to diagramming transformers for radios and televisions that I forget that test equipment is different. And this one, I totally neglected the high voltage winding, which runs from the plate all the way down to the filament of the half-wave rectifier. And just want to go ahead and give y'all a corrected schematic on that. And I've wrought the numbers a little bit too, like I got 365 volts, you'll see that's now 372. Just trying to make the math add up a little bit better for everybody in this. If you're testing a power transformer in one of these scopes. But this one right here, yeah, that's, can't use that. But here is the corrected power transformer schematic. And on the high voltage winding, I did not try to go all the way from the plate of the full wave rectifier to the filament of the half wave rectifier. That's just basically trying not to peg my meters, and it also just felt safer to go from right between here, right, just measure it directly from point to point here. Where I got on the Variac at 115 volts, I got 610 volts AC, and then plugged into the regular power here in the shop, it was 647 volts AC. And the power here in my shop kind of fluctuates between 120 volts AC and 125 volts AC throughout the day. So all of these readings are approximations just to help out anybody who might be working on one of these scopes. And on this winding right here, I'm trying not to do this in shaky vision, but your scope might be wired differently from this, but this one has a solid blue wire that is not braided, running to pin 2 of the half-wave rectifier for the high voltage. And then it has just a regular braided wire like it does everywhere else running to one of the plates of the full wave rectifier. Don't take my notes here about pin 6, you know, that might be pin 4 on yours. So just bear that in mind, and I just want to throw this in to help anybody out there who's looking for basically, approximate readings to check these power transformers in these. I really like these moments, these small step-by-step victories in reviving essentially untouched equipment. It's just that thought that none of these tubes have been lit under the power of this oscilloscope for 40 years at least, and there they are, just glowing happily. No B plus, no anything else yet, but even the pilot light is still good somehow. Don't often find that. Most of the time the pilot light will be one of the components that's burned out. I've had it on now for a few hours, and I like to do that just to see how much the transformer and equipment like this heats up before I go investing a lot in it. And it is very, very comfortable to the touch after a few hours. About 3.5 hours, it's just a little touch above room temperature. Of course, that's with the B plus unloaded, but that is more than good enough for me. And off camera, since I've been working on this, I've been diagramming all of it. I haven't reverse engineered a schematic. I don't do that unless I absolutely get into a bind and have to. But just in preparation for applying more power to this, I like to always just do a rough diagram showing the component values and locations, just in case something decides to go up in smoke. So I'll show y'all what I've got on all of that so far. Anytime I don't have any service information on equipment that I actually plan to keep and use, I like to compile my own just roughly as best I can. So here's what I've got so far. The beginning of the triode section that I concluded here, I duplicated on the next page. So just in case anybody else is on one of these and needing kind of a roadmap, if you will, I'm going to share this with y'all, and y'all can kind of freeze and zoom in. All the potentiometers checked real good. I was poking and prodding around on resistors while I was doing this, and the potentiometers checked great as far as resistance. Of course, they're needing to be cleaned. They're all somewhat erratic, but in the process of compiling all of this, I, not too surprisingly, ran across some of the old roundy type carbon comp resistors that were highly questionable, and I ran across one that is just absolutely bad. Right here, right on the focus control, from the focus control to the horizontal position control, 470,000 ohm roundy type, appearing to be a 1 watt. Right there, and it kind of pays to poke and prod around just kind of aimlessly on stuff while you're exploring it. And here is the reading off of that 470,000 ohm resistor with the meter set to the 1 meg scale. All right, we're passing 8 million, 9 million, 10 million. This thing, let me cut it back, put a little more load across it so it'll act quicker. It just kept right on going and going and going. This is on the times 100,000 scale. Until finally it settled somewhere above 50 million ohms. So there's absolutely no need to even hope for anything usable to apply B plus to this until this resistor is replaced. And looking at it, you'll see that it's not charred at all. It does not appear to have ever overheated. But these old rounded type carbon comp resistors, like I said earlier in the beginning of this video, they have a tendency to just fail with age, and this one right here pretty obviously just got tired of waiting around and basically said, you know, screw it, I'm out of here. So I'm gonna have to go ahead and change this resistor. It'd be pointless to even try applying any real B plus to this with that in there. Many hours later. Yeah, there was no sound effect that actually said that, so I'm just gonna say it myself. It's many hours later. Okay, well, I've got the recapping done, and I got problems here. And rotted carbon comp resistor be thy name. Okay, but starting with the recapping, they all had to come out, y'all. I was really hoping that these half microfarad at 400 volt would be usable, but they're not, and nor were any of the others. All of these capacitors, all of them, not a single one will withstand a test of all of 8 to 15 volts without just leaking terribly. So they all had to come out. I was hoping to maybe leave a few in for a time, but not only will they not charge at just 8 to 15 volts, but they go down the longer the test runs on them. They don't heal, they just leak worse. So all of these had to come out. Also, I've changed out the original filter capacitor. 3 10 microfarad sections rated at 450 volts. I had a 4-section twist lock type to go in there that I've never used, and it's been in my stock for years, so use it or lose it. So I put that in. This resistor I started with, that was between the focus control and the horizontal position control. once it was out of there, it actually tested almost to infinity, about 650 million ohms on this 470,000 ohm resistor, and that's just the tip of the iceberg. Found this one open as a barn door, also not charred. This was on the sweep range selector switch assembly and totally opened. All the carbon comp resistors in this scope are basically just roached. When I got into recapping and really checking these, I mean, they are terrible. Got a 680 ohm, if you can see it tucked right there, and it reads about 2,000. A lot of the others, basically none of them save, just a very few, less than 10 are in spec. But the ones outside of spec are not so wildly out till they're just entirely not worth trying. I said in the beginning that I didn't have these half microfarads at 400. Well, I had to pull a substitution on these, all of them. So you'll see here I installed a 0.65 rated at 200. Here is another 0.65 rated at 200. Down here on the horizontal input, there's a 0.62 rated at 200. Here's a 0.47 rated at 200. And on the sweep range, I also installed a 0.47 at 200. The direction of this project has changed now, given that it would have to have just a full carbon comp refit throughout. This was supposed to be a revival, not a rebuild, so I'm trying to hold to that. All of these 200 volt rated capacitors, these are, I don't know if they're poly capacitors, and they all check leakage free up to all of 200 volts. Given the surge rating on these, I figured they were worth a try. These 0.65s and 0.62s, I don't have a lot of call for them, and they've been in my stock forever, so given that it's going to take a lot of pretty much all the carbon comp resistors in this scope being replaced to really bring it back to full function, the best function that it can have, I dug heavy into my new old parts stock and decided to go ahead and just pull some substitutions on this. On the line bypass capacitors that were originally 0.1 at 400, I've got these 082s that are close enough, and I don't really have a lot of call for them in radio and the TV work that I'm doing here, so I had these two handy, so I stuck them in here. Other than that, these plate coupling capacitors for the deflection plates, they were originally 0.1 microfarad, get your finger out of the shot, Pierce, 0.1 microfarad at 400 volts. They are now 0.15s rated at 600 volts. All of these capacitors have been that I've installed, even though they're old stock, they've all been checked to all of 400 volts, and the 600 volt ones have been tested up to a full better than 500 volts. Actually, these 200 volt rated ones, I went all the way up to about 427, 430 volts with them to load test them for leakage. So I feel pretty good that it's a lot better off with these than it would ever have been trying to fire it up with these suckers right here. So yeah, I'm economizing a lot on this, and kind of wondering now, will this thing ever really be usable without just a full entire rebuild? Maybe not, but the point of this video was just, to try to see how well it'll do with as many of its original components as possible. But I'm stopped right now because I hit another problem. The doggone vertical gain control, which actually the potentiometers, as I said earlier, they were checking good. Removing the input coupling capacitor, a 0.25 at 400, which I've actually got this replacement lined up for, apparently killed the vertical gain control on this. It is now opened as a barn door, which I hate that. Now, vertical gain controls on old scopes, you're going to frequently find them replaced, but this scope still had all the original potentiometers, and I really hate that 1 megohm vertical gain potentiometer is now obliterated, and I intend to take it out and do an autopsy on that to see if maybe I can repair it. Probably not. I'm just going to have to hunt a replacement for it, but I want to at least do an autopsy on it. This is real world, y'all. 67-year-old oscilloscopes don't revive without hitting some snags, and this is the snag I have now hit on this one. I hope I can find one that'll still enable the knob to look original. Like I said, a lot of scopes, the vertical gain controls get knocked out on them, and it's actually, in my experience, kind of rare to find a scope where that's still original. My old Konar over here, the one in it had been replaced by the time I came by it, so I'm pretty used to, no real big shock there, other than, I'm gonna hate it if my touching it with a soldering iron to get that original coupling capacitor out is what killed it. But there's another thing while looking through this that I want to call your attention to, and while I'm working on a potentiometer solution, there's another thing I'm going to have going on here. I had to take the CRT out to get room to mount a larger diameter twist lock capacitor in this, and this one's got all of what we need here. It's got 3 10 microfarad sections rated at 450 volts, and an additional 20 microfarad section at 450 volts, which I kind of hate to waste when it's not going to be needed in this. But looking at the date on this, it's a new part, never been used, never been hooked up in anything, but a 2010 part, use it or lose it. So I went ahead and did that because the original capacitor in here, y'all, nothing but corrosion is basically what we have in this now. It's not a maraca, you know, it doesn't rattle when you shake it, but practically all that's left of this original power supply filter is the it's all power factor now, high power factor. All sections of it checked like 12 and 13 microfarads using a digital meter, but when I got it on the tester over here, here's what actually was going on with it. One section was 5.3 microfarads with a 70% power factor. Another one, 6.5 microfarads at a 78% power factor. And finally, the third section was 4.6 microfarads with a 63% power factor. And that one actually withstood the most voltage, you know, as far as charging. I mean, it made it up to 102 volts. So, 6.5 section there wouldn't charge beyond 4 volts. But anyhow, here's the new one, and all sections of this new one are testing very well, all the way up to 450 volts. So I'll go ahead and use it in this scope, at least for a while, and we'll see how this thing works, you know. But the other thing I got thinking about was, let me slip around here, honey. Unplugging the CRT, I really got looking at this, and most oscilloscopes have like a wafer socket in them, which allows, you know, better spacing between the terminals. But it looks to me like EICO really just kind of chose to use an Archmatic 2000 in this. So I mean, the camera's showing actually more space between these terminals than what there is. I mean, it is tight with all the high potential voltages. And yeah, I've got some nerve shock after all this recapping, so I'm videoing in shaky vision here. Sorry, but this just looks like an arc over a circus waiting to happen. So while I'm investigating that potentiometer, I'm going to go ahead and coat this with Corona dope, and I'm not even going to give this a chance to light up like the 4th of July, because with my higher line voltage now than what this scope probably was operating on years ago, and also the higher efficiency of the new main power supply filter, I think there's an increased arc over possibility here. Basically, capacitor wise, there are 3 that I left in. Old oil type capacitors are very durable, and this thing right here, just to the highest voltage I could test it, which was actually about 525 volts. It checked fine, and it checks absolutely dead on in capacitance. It checks 1 microfarad exactly. And I don't have a replacement for it, so I'm going to try to trust that this thing right here will actually last for a while. But it is one of only 3 capacitors that I have been able to leave in this scope. The other 2 are these 2 box type microcapacitors here on the coarse frequency select. I don't know, the color codes on these types of capacitors are notoriously unreliable. I haven't really searched hard for a schematic on this, but at 500, better than 500 volts, they check leakage free, so I'm just going to trust and try to leave these in. But this is where I am right now, and I am just about I'm knackered. Uh, I'm about cross-eyed after all of the recapping work and everything. One last thing. When I installed this new multi-cell capacitor, I find they kind of tend to rebel against having their terminals heavily loaded, so I did install a terminal strip to mount the resistors, and that way I've got a good, quick, easy disconnect on this should this project yet decide to go south. So that's where I am, and I'm about to pull that potentiometer out and learn only that it's unrepairable. Okay, I've got the vertical gain potentiometer out, and I'm going to finish off tonight by giving y'all a quick demonstration, hopefully a quick one, on how to get potentiometers apart in order to test and clean, service them, or just do an autopsy, which that's probably what this will be. They don't all go together the same way. Ones like this one have a ring that you can see right here on the shaft, and it's got a gap in it. And first thing you need to do is get this out. And if you have the proper tool, I'm sure it's easy, but using jeweler's drivers like I use kind of make it a pain in the butt. And then otherwise, you just bend back all of these locking tabs, and then it just pulls apart. But you need to get the ring out on one like these first, this retaining ring, because if you take the back off of the potentiometer first, when you clamp it into a vise or whatever you're using to hold it, you risk cracking the phenolic, and that's just not good for anybody. So I'm going to try to go ahead and right quick get into this, and we'll see what we see. Okay, y'all didn't need to hear every single utterance I was making through this, but it finally gave. It finally gave. It is actually loose now, as you can see. I had to stop and adapt my method. Ended up using a combination of these in awkward positions to actually get it to start expanding. But now it is finally ready to come out of here, hopefully. Or I might have to finish it off that way. You never can tell. I'll get to see it done some one way and then some another way, I guess. But here we go. Here we go. Come on. Come on, come on, come on, come on. Oh, there we are. There we are. And half the time they'll pop clear across to the other side of the room or into the next room, but you need to hold on to that. You need to find it if you lose it, because you will, in the case of a potentiometer you're planning to reuse, you're going to need it. So we'll drop that right here, and then we will go ahead and start bending these back. And this is how I end up with all these scars and all on my hands, y'all. I'm an old hand at doing this, and therefore my hands look old. But I'm just going to use a jeweler's driver to just start all of these back. All I'm trying to do is just get them back far enough to get a grip on them, and still try not to exert too much pressure on the phenolic, just in case it's repairable, even though it's probably not. And then we'll straighten these on out. Be careful not to break them. Most of the time they can withstand this at least once without breaking. There have been some that I've worked on multiple times, but the more you bend those, the more chance you have that they're going to break. But anyway, there we are. It's apart, it's out of here. And with that ring out, now I can theoretically take that off. And we will look at this. And I don't see a thing in the world wrong with it. Let's get it over here where I can take a better look. Okay, the resistive element in this, which is just a coating, is gone. I don't know if the camera's going to catch all of this, but if you look, you can see right here right at the terminal, you can see the carbon resistance coating right here, right at the beginning of this terminal, and right at the beginning of this terminal. And then otherwise, all that's left beyond just a little bit coming up to right here, that's all that's left of it. We've got carbon, 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 and then it's just phenolic all the way around here until right there at the very end we have carbon again. And looking inside the back of it, you can see the remains of it. It's just, it's very, very thin in this one. Some potentiometers, it's heavier, but it's very exceedingly thin material, just hair thin. That's the resistive coating on that was on the phenolic substrate here, and it's just obliterated, it's gone. So I feel a little bit better now because my soldering on either of those terminals did not do this. This control was already roached. It was already flaking apart internally. Kind of hard to believe that it was still checking as good as it was, but just a few rotations, and even if everything else had gone fine, this one would have been gone. So it was just barely hanging on and waiting for me to come along and touch it. So probably what happened was sometime when this scope was last used originally, this leaking input coupling capacitor probably allowed too much current to hit this sucker and damaged it, and then it was just waiting for me to work with it a little bit to finish it off. So at least I didn't kill it, and I can sleep soundly tonight knowing that. So I'll see y'all tomorrow, and we'll start again, and tomorrow we'll begin with the search for a replacement vertical gain potentiometer. But looking at how thin all of this is, really kind of makes me wonder about the condition of the other potentiometers in this that are checking kind of resistively okay, but function wise kind of erratic. This is a very, very thin coating. But anyway, that's it for this one. It's roached. So tomorrow's a new day. Okay, and now we're into another new day. Whew! Alright, it's now or never. So, we're about to try to fire this up with some B+, not full B+. I'm going to run it on reduced voltage since the capacitors I installed are undersized voltage-wise. I don't want to push it too far. And y'all just know that if this thing looks like it'll work out, all those 200 volt capacitors, they're going to be replaced with 400 volt to 600 volt, especially here on the inputs, because I want this thing to have more cushion against higher voltages than just like 200 or 400 volts. So definitely on the inputs, if I end up replacing, really deciding to keep this, we're going to have 600 volt rated capacitors on the vertical input and the horizontal input. And look at how well the BNC connectors worked out. I didn't even measure, y'all. That's just strictly by guesstimation. Worked out pretty well. Anyway, let's see if all this was worth it. And I've got my meters pulled out, haven't hooked them up yet. But when I fire this up, I'm going to start it at reduced voltage, I think about 50 or 60 volts. And we'll walk it up from there. And I'm going to have these meters just don't go by any of the voltage readings I'm getting, because I just want to make sure at this stage that all the B plus voltages are coming up. And if they don't appear to be, I'm going to shut it down before a power transformer or anything has a chance to go up in smoke. We're just doing a revival here, and I'm going to try to give it enough line voltage to get a good idea of how well this will perform at regular line voltage. But I'm not going to take it up to full line voltage in this video. So I guess I'll be back with y'all in a moment, and we'll get this EICO show on the road. Okay, here we go, y'all. I've got 3 meters hooked up. I started to go with 4, but I decided the 4th one wasn't necessary. This one right here, this first vacuum tube voltmeter, and this one above it, I have hooked to the output sections of the main power supply filter right here. I was going to do one to measure the raw B plus going in, but that wasn't necessary. If everything's all right at that point, the voltage at the outputs will be coming up. So these two are set to confirm that B plus is rising on the 2 output sections of the main power supply filter. And this one I have reverse connected because it only goes up to 1,000 volts on this one, but I'm gonna watch. I want to see the voltage rise on this honey right here, which operates at beyond 1,000 volts. So I might have to disconnect that one, but on this first fire up, I wanted to go ahead and monitor that too. So I'm monitoring from the 2 output sections of the main filter and the output of this capacitor right here for the negative high voltage supply for the CRT. So without further ado, we're going to go ahead and switch on. Come back, honey. I'm going to go ahead and switch on right there. And my variac is set to 0. So I'm going to switch it on, and we're just going to we'll go ahead and come up to about 50 volts here and see. Okay, we're getting some rise there. Boy, we're already at negative 535 volts on the CRT circuit. So let's see, this one's right here is set to the 500 volt DC scale. So we're at about 230 volts there, and this one's set to the 1500 volt scale. So here we are using the 3rd scale down on this one. All right, it's got just a dim glow from the pilot light here. I think this one right here is the one I'm going to have to really keep an eye on. We're going to ease her on up here. I'm tempted to just go ahead now and disconnect my meters, but I'd like to get some kind of a indication here. Maybe it'd help if I turn my sun down a little bit in here. There we go. We're into a new day, and it's kind of a cloudy day, so let's see, we're gonna go intensity wide. Whoa, look at there. We got a spot. We have got a spot, y'all. We've got a spot at about 60 volts. It's a dim spot, but it's definitely, oh, look at that. Sharpens right. Using the focus, okay. Let's try vertical position, move it down a little bit. Horizontal position. Get it about right there, that's roughly about centered. Looks like it's gone kind of dim. But we are at about 60 volts. We'll come on up to 70. Definite sign of life. Kind of jumping around a little. Responds to the coarse frequency select. What are we up to on B+? Okay. Bring that on up about 250. And we are at 707 volts. Well, 708 volts now on the negative high voltage. Lost our spot. It keeps wanting to run away from me. Get back there, fella. Let's see here. My main concern about those lower voltage rated capacitors is I don't want to burn up another potentiometer in this thing. Carbon comp resistors, I'm all right with. If they want to fail, and in this one I think they do. But 826. All right, that's actually looking pretty good. And we are about at, we're just shy of about 90 volts. Can we come on up? Will it let us come on up to 90? I think I'm going to hold it about right there. We've got B plus running at over 300 now. Yeah, I think I'm going to hold it about right there. But look at here. Look at here, look at here. Let's see. Turn the intensity back, and we've got to use maximum intensity. Let's see about our focus. We got range on both sides. of the focus control. And that actually looks pretty good. All right. At this point, I want to go ahead and disconnect my meters. We've got a definite confirmation that we got some definite life signs here. I'll tell you what I'll do. Got a little length of wire here. We'll try going from the 60 cycle test. I kind of like the look of these suckers right here, but I think if I'm going to really be using this, I want to have it, boy, just touching that. We got some, yeah, okay. Let's see, I'll stick that on there if I can. One-handed. We'll see what the, we'll see if we can go ahead and get some kind of a pattern on this. All right, might have to do it off camera. That's the way it goes for me. Yeah, definitely gonna want to change these for banana plugs. But we got a little response just to that wire being hooked up, just handling it. Let's go to the 60 cycle test. Going into the vertical input and see what we got. So far all we're getting is a guy fumbling around with a scope on YouTube. But I don't want to cheat y'all out of the first fire up on this. I want to bring y'all in for the full ride. All right, that's firm. And now what do we have? Sync internal. External. We lost it. That's on horizontal input. Come on. Haven't quite. Let me cut my shop light down. Just turn it off. Get everything. All right, that's where we are. Let's see here. Course frequency select. I'll have like, I'm looking for a come on over. Move. Looking for a sine wave, but not getting it. Wait a minute, wait a minute, wait a minute. Wake up, honey. Might still have another. Let's see, horizontal gain. Let me cut that back. There we go. There we are. Crooked. Crooked, crooked, crooked. But we've got a sine wave. Let's see, we'll bring it up. Don't try this at home. Make sure, you notice I put a little glue right here to make sure that the socket turns with the tube here. Be careful about turning the CRTs in a scope because it's very easy for that socket to be loose and to break a connection in the base of the tube. But yeah, let's see, can we let me nudge you a little bit further? There we are. Look at there. We got a sine wave, and we're going to come up with our vertical. All right, let's give it some more horizontal gain. Horizontal position. Come over a little bit. There you are. Okay. We're on the 15 to 75 hertz range. Let's see if we can stabilize this. We'll try to sync it. There we go. There we go. And so far, not clipping too bad. Let's see, focus again. Pretty good sharp focus on that. We'll try our fine frequency down here. And our sync. First sine wave in about what y'all want to reckon? 40, 50 years? Well, no. But the last time he used it was 1982. Y'all do the math on that while I try to. It's bugging me that CRT is just wanting to. My OCD can't handle that. But look there. Oh, now I've gone too far. Okay, fine frequency. Let's see if we can stabilize it. Come on, like really. Look at that. Look at that on its own 60 hertz test. That is looking mighty good to me. We're running at maximum intensity. We're up to 880 some odd volts on our negative high voltage. Oh, about 310 volts on our higher B+. But like I said, all of that's, neither here nor there right now. But that is a pretty good looking sine wave. For a first time fire up, let's see, we'll move up from 15 to 75 to 75 to 400, and we'll see if we can sync it again. Running back. No, we can't, so I'll leave that at mid-range and we'll try our fine frequency again. And Yeah, we got a little compression going on. But still, I'm happy. This tells me for sure I've got a good CRT in this. Ooh, and it's kind of touchy. This tells me for sure we have got a good CRT. Let's see about our horizontal gain. Working really smooth. All right, vertical gain. Just bring it down. Whoa, that's vertical position. Working through camera, y'all. Okay. That's at 0, so I'm going to try to get back here where y'all can see. I'm just going to bring it up slowly. And we're now at a little past 30. But actually working smooth. All right. We'll go from 75 to 400 to 400 to 2000. Nothing. Oh, there we go. There we go. All right, where are we? From 2,000 to 10,000. All right. I can't go any higher on the intensity unless I bring the line voltage up further, but like I said, going on fine frequency here to try to stabilize that as much as I can. All right, let's try our sync on that now. All right. And our sync control action seems to be smooth. So far, I am liking this. Let's go back to 400 to 2000. There we are. Yeah, we're gonna need some, let's see, sync. Horizontal gain. There we go. Horizontal position. Okay, and now we'll just jump to the 10,000 to 75,000. And it wants to be stubborn. All right, come on. All right, old switch. Oxidized contacts need to be cleaned. we're gonna just go right back to right here, 15 to 75, and we'll sync that if we can. Find frequency. Oh, come on, honey. Hold still, would you? But it's alive. It lives. Let me pull these blinds. Just keep going darker and darker. There we are. +60 years old. And I wonder if I dare take it on up to about 95 volts. Getting close to maxing out my meter there. Okay, we're at about 325. I am gonna hold it right there, y'all. As far as I'm concerned, this is revived enough to, let's try a square wave on it. Let me get my meters, just get my meters off of it now, and we'll play around a little. Looking good, looking good. Oh, I'm loving this. Oh, look at that. Let's bring our horizontal gain in some. There you are. And only at 95 volts. So let's try our focus. Oh gosh, we got plenty of focus range on this. All kind of focus range, and I like that it's most sharp at about mid-range, so it's still got so much room on each side of the focus control. Okay, I had a few errands to run, and increase my vertical gain here. Horizontal gain. Decrease my vertical gain. Okay, that's looking pretty flat on the 75 to 400 cycle range. Let's drop back here on the 15 to 75 cycle range, and okay, got a little wave going on there. But y'all, I'm using this old EICO 377 audio generator to obtain this square wave. So which one is the error really occurring in? That which is sorely in need of service after all these years. It's still got the electrolytics in it, the original ones. Or is it in the scope that has just been revived? Horizontal gain, our sync's holding really, really steady. I believe all of this is occurring right there. Okay, but let's see here. We'll go and adjust our fine frequency. Let's see how much we can get right here. Okay, let me come on up. Pretty well synced right there. Let's. Oh, look, we got a little more intensity. I forgot I had turned the intensity down. Yeah, my audio generator definitely needs service. But we'll continue on with our fine frequency here. We'll just keep counting down. There we go. There we go. 15 to 75 hertz range, fine frequency between 80 and 90, and our sync at about 65. Decrease our vertical gain some, and oh, look at that. Yeah, we got a little bit of overshoot, which more modern scopes would edit out, but gosh, this is fun. I love this. I love when projects like this start actually coming together. And I'm just working the fine frequency now. It's kind of sad for it to be necessary, but this 377 up here will be an upcoming project. Like I said, it still has the original electrolytics in it, and that'll be an upcoming project here. EICO to EICO. I'm going to go ahead and run this on up to about 1,000 hertz. I'm on this second scale right here on band B, from 200 to 2,000 hertz. And now we'll see what we got. Okay, look at there. Look at there. All right. So I'm going to gain up a little bit. Whoa, that's vertical position. Again, working through a camera, y'all. Apologies. Alright, see if I can sync that a little better. Okay, now on the fine frequency, we'll see what we can reduce that to. Oh yeah. Okay, vertical gain, horizontal gain. Okay, now we're going to switch to the 400 to 2000 hertz range. And again on the fine frequency. Oh, look at that. Look at that. And at 95 volts, right now our vertical gain on the scope is set just a little above 20, and that's matching our horizontal gain. That used potentiometer I found for the vertical gain control actually seems to be matching the original 1 meg ohm for the horizontal gain control pretty well, and that's desirable. Okay, so we'll come on up here to the 2 kilohertz to 10 kilohertz range. Oh gosh, let's see, I'm walking on back. Good enough for now. See if I can sharpen it up a little. Of course, some of that's affected by the gain on this, the output on this as well, which is, I'm going to drop it back to about 10. Okay, and there we are. If I walk it back some, well, try to sync that again. There we are. Wants to have a little upward turn down here, but I think this scope is a keeper. I like it. I like it. I like it, just playing around with these old scopes. I I love to do that. Come on up here to from, well, come on, there we are. All right, fine frequency, come on. All right, but let me drop it back down here to right here, and now I'm just playing. All right, let's try the XY operation on this and see how that works. So I'm going to disconnect the from right here, and I'm going to reconnect the vertical input to the 60 cycle test, and we'll go in from the signal generator on the horizontal and see what we get. All right, we're back on the 60 cycle test and got it doing its cool continuous sweep writing. All right, so I'll sync that now. There we go. All right, we're about to check out the XY operation on this. So I'm going to connect the input from the audio generator to the horizontal input and have it pop off repeatedly on camera. Yeah, banana plugs are definitely in the future of this scope. All right, now I'm going to switch the horizontal input to external. And we get this curious little pattern here. Let me add some horizontal gain to that. And the clip pops off. This is how my clips get worn out here. But there we are. And that is not a Lysogyl pattern, obviously, because I've still got the 377 set to square wave. So I'm gonna take it back here. We're gonna go to band A, and we're gonna go back to 60 hertz. Still on square wave at the moment. And here we see the result. 60 hertz square wave feeding in on the horizontal, and 60 hertz test feeding into the vertical input from the scope itself. But let me now flip this to sine wave. Look out. Look out. Still looking pretty square. So I'm just going to fine tune generator up here, and we'll see what kind of linearity capability we got right now on this. Alright, that was moving down, and we're gonna come back up. There we are. There we are. XY operation. And still really sharp focus. I've got the horizontal gain set to about 80, a little better. Vertical gain set to a little better than 20. And rightfully I would be measuring the peak-to-peak volts from this, but this is mainly what I was after, just the basic test here. Alright, so we'll go and there we have it. Oh, 67, 68-year-old oscilloscope. And I can't wait to get the proper capacitors and all for this, and really start checking into its true capabilities. Hard to believe it was in use all the way until 1982, but like I said, in the beginning of this video, he would have by that time been working on televisions manufactured back during the 60s and 70s primarily, and old scopes like this, even though their bandwidth was severely limited, they do all the basic measurements that he would have needed, even on up into probably the early 80s. But this is shaped up a whole lot better than I originally, for a while there, was thinking it would. I wish I'd had the capacitors to go ahead and put the proper volt rated capacitors in it and operate it at full line voltage. But we're still actually a little better than 95 volts, and I'm happy with this. The capacitors I installed are holding really well. It's just, you know, such as it is, it's stable as it can be. And we don't have a, like, you know, a perfect pattern here, but gosh, y'all, for a scope manufactured back in the 60s, receiving a signal from audio generator manufactured back in the 60s, scope from the 50s, audio generator from the 60s, why it's still got its original filter capacitors in it. This has really worked out pretty well. I am really liking the way this has turned out. I want to go ahead and pursue getting all the parts and everything, and getting this fully functional. Recapping might do a whole lot for it, because at less than 100 volts AC, we've got all of these results from it. Here's the money shot, by the way, for people who like it. And the pilot light's still glowing dim, and the tube heaters are still glowing dim. Can't even hardly see the heater back here in the back of the CRT, but there it is. There's a reflection of it. So I'm really happy with the way this has turned out so far, and I'm definitely, you're going to be seeing more of this scope, because we're going to keep going with this, and I'm going to get the parts and the proper parts and do this up proper. I am kind of thinking that the 0.65 or 0.62 microfarad capacitors in the grid circuits I might leave in, because in the grid circuits we're nowhere near like 200 volts, and they're rated for 200 volts, and use it or lose it, and I do kind of operate on a budget here. But this has really worked out well. And next time you see it, it's going to be back in its case, all cleaned up and everything, and we'll see how much work we can get done with this. This ought to work pretty well with everything that I'm planning to do here. A lot of the old tube type work. It ought to be just fine. But anyway, y'all, that's all we have for now. And y'all take care of each other out there. And I believe this is the way to do old projects like this, because I had no idea of the condition of the CRT in this when I started out. And the 56 Olympic I mentioned, which will be coming back. I've still got that television, and I mean to get it playing if it's the last thing I ever do in this life. But I'm going to try to get that Olympic playing, and I'm pretty sure this will come in handy when I get around to that. So that's one project in the future that you'll almost definitely see this EICO 425 used on. And in the meantime, just going to have to see how everything goes, because my need for an oscilloscope kind of originated from the 1956 Olympic going the way it did, and my Conar over here breaking down on me. But this is really, yeah, that's not perfect linearity, but like I said, 67-year-old oscilloscope. I mean, come on now. What more can you hope for? So, we're going to have more on this EICO coming up. And in the meantime, take care of each other. Do something you love and never work again. And we'll see you next time here on Brooks Hobby Shop. We're out. This EICO to that EICO, sitting by the fire. One EICO said to that EICO, I'm gonna set your soul on fire. Talk about hey now, hey now, hey now, hey now. EICO, EICO, EICO. I couldn't resist, y'all. When will I ever get another chance to do that on YouTube? Anyway, y'all take care. Brooks Hobby Shop. We are out. Good to the last drop.